Hello and welcome to section 3.5. This is limits of infinity, or limits at infinity, and basically we're going to find out what happens as our graphs go out to infinity. And so in this section, this is basically going to define all of our stuff that we've learned in Algebra 2 and in pre-calc about limits, or about horizontal asymptotes. And so in this section you got to kind of think these are horizontal asymptotes, and so it's the end behavior of the function as we head out towards infinity. So you can look and see this graph. If I was to graph 3x squared over x squared plus 1, I would get this graph down here. And as I approach negative infinity or positive infinity, you'll see that my graph is approaching 3. So that is the end behavior of the graph, which would end up giving us a horizontal asymptote. And you can kind of see this with the table of values, if that was a way you'd want to see it besides the graph. And so just kind of looking through this stuff, you might want to get some of this stuff down. But we're trying to find out, whenever we're dealing with a limit as it goes to infinity, we're just trying to find out its end behavior. And so all those rules that you've learned about limits to infinity over the past few years, this will hopefully define them for you and give you a way so you don't really have to memorize them, just give you a way to kind of use them. All right, and so basically the line L that is our horizontal asymptote, basically, that we're approaching as we do a limit to infinity. So that's really all we're talking about, is that you can have at most 2 horizontal asymptotes when you're dealing with a graph. You can have an unlimited amount of vertical asymptotes, but horizontal you can have at least 2. At most 2. And that's really what's happening here. When we approach from negative infinity or positive infinity, you could have one where it approaches L and another one where it approaches K. So that's really what we're talking about. And so when we do limits to infinity, it will still work. You can add limits together. Basically, our properties still hold. We can add them together and we can multiply them, and we can still find out what's going on with those limits, as long as f and g both exist. So just kind of keep track of these things. These are things that we will be using in this section. And so make sure you get these down. And so then we finally have a theorem that deals with our limits to at infinity. And our limits at infinity is basically, if we have a real number and we're going to take x as it approaches some value, if we make that go to infinity, we end up getting 0. And think about this. I mean, you're taking some number and dividing it by something really, really large, the biggest number you could possibly think of. And so although it's going to be a really, really small number, that's why we're calling it 0. We're saying it's basically approaching 0, and therefore we can deal with that limit, and it makes our lives easier, and we'll be dealing with that in a little bit. So then if I was asked to find the limit as we approach infinity of this graph, you could do it a couple different ways, but I'm going to break this apart, just trying to remember our properties of limits. And our limit as x approaches infinity of 5, and I'm going to subtract my limit as x approaches infinity of 2 over x squared. And the reason I would do that is that's basically what you're doing before when we were doing these problems. We break them apart. Remember that a limit of any constant is always just going to be that number, so that is 5 for that value. And then here, this was the previous property that I was showing you, that if I take this to infinity, 2 over infinity squared is going to be a really, really small number, so we're going to basically call it 0. And so then we end up with 5 as our limit for this function. And that's really all we're trying to do when we're trying to find our limits at infinity. And so then here's our guidelines that we need to remember. If the numerator is less than the degree of the denominator, then the limit the limit of the rational function is 0. And these were the rules that you learned these in pre-calc and algebra 2. And so when we come to class, we'll demonstrate exactly how these work. So make sure you get these down, and I'm not going to read through them for you. You can go ahead and get them down. And I will see you in class. If you have any questions, please come to class prepared to ask them.